All right, welcome back to Peak Pilot 360. Imagine you're in the interview. The captain across the table leans forward and asks, "You're at flight level 350 and you get an unreliable airspeed warning on the ECAM. What are your immediate memory items?" It's a tough question, and your answer could make or break the interview. Stick with me, and by the end of this explainer, you'll know exactly how to nail it.
So let's break this down. This is the heart of the problem, isn't it? If you fly too slow, you're looking at a stall. You lose lift. If you fly too fast, you risk exceeding the structural limits of the airframe. When that speed tape is telling you lies, you're essentially flying blind between two invisible and very real dangers. So what's the procedure? What do you do?
Well, this isn't some made-up scenario for a movie. What you're looking at here is a real-deal emergency checklist. Unreliable speed indication is what we call a memory item. You have to know these actions cold, by heart, because when this happens for real, there is absolutely no time to be fumbling around for the QRH.
The answer isn't some other piece of fancy tech. In fact, it's the opposite. The procedure is to strip everything away. You've got to ignore the bad data the computers are feeding you and get back to the absolute fundamentals, the raw relationship between you, your engines, and the air.
And this, right here, is the core of it all. It's a simple, beautiful formula every single pilot lives by. Thrust is the power you command from the engines. Attitude is the pitch of the aircraft's nose against the horizon. You, the pilot, control those two things. And when you set a known thrust and a known attitude, you get a predictable performance, a predictable speed. It's cause and effect flying, not just reading a screen.
So, why does this work? Why can we trust this simple formula when we can't trust a multi-million-dollar avionics suite? Well, it's because it's all grounded in the fundamental physics of flight, the four forces that keep that big machine in the sky.
You know, we talk a lot about speed generating lift, but that's really only half the picture. The real hero here is the angle of attack, the AOA. That's the angle where the wing meets the oncoming air. Now listen, no matter your speed, no matter your weight or altitude, a wing will always stall at the exact same critical angle of attack. So by controlling your attitude, you're actually taking control of that vital angle.
And this image shows that constant balancing act we're always in. For an aircraft to fly straight and level, these four forces have got to be in equilibrium. You've got thrust from the engines fighting against drag, and at the same time, lift from the wings is fighting against the airplane's weight. Every input a pilot makes is about managing this balance to climb, descend, or turn. This little table makes it even clearer. An interviewer might ask you, which of the four forces do you directly control? And the answer is simple. You directly control thrust with the thrust levers, and you directly influence lift and drag by manipulating the airplane's attitude, which changes your angle of attack. Weight is, well, pretty much fixed for the moment.
So here's the bottom line. Even when your airspeed indicator is shot, you still have the two primary controls you need to safely fly the aircraft. Set the thrust, set the attitude. You're no longer relying on a sensor, you are flying the aircraft based on first principles.
Okay, so the theory makes sense, but how does this actually work in the cockpit, at 30,000 feet with passengers in the back? It comes down to flying by a set of numbers you know you can trust.
Here's the drill. First thing, you disconnect the automation. Get the autopilot and autothrust out of the loop because they're being fed bad information. You take manual control. Next, you set a known, memorized power setting. You hold the airplane level using your attitude indicator, and you just see what pitch attitude it settles into. That attitude now becomes your new airspeed indicator.
It's really intuitive when you think about it. For a given amount of power, if you have to keep pulling the nose way up to stay level, what does that tell you? It means the wings are struggling for lift, you're getting too slow. And if you find yourself having to push the nose down to stop from climbing, you've got excess energy, you're too fast. The attitude indicator tells you everything you need to know.
And look, you don't have to guess these numbers. In your quick reference handbook, your QRH, you have tables just like this. So for an Airbus A320, clean configuration at about 60 tons. Below flight level 250, the book says to set 60% N1. If you do that, you should get a pitch attitude of about 4 degrees nose up. And if you get that, you can be confident you're flying safely around 225 knots. It's a proven recipe for safe flight.
So what causes such a critical failure? And more importantly, what does this whole situation teach us about our role as pilots in a world of ever-increasing automation?
Believe it or not, our entire airspeed indication system often boils down to these tiny little probes. You can see them here. The pitot tubes face forward into the wind, measuring total pressure, while the static ports measure the ambient air pressure. The computer does some quick math with the difference, and voila, you have airspeed. But
They can get blocked. Ice, insects, even a forgotten cover on the ground can take out the whole system.
I love this quote from an Airbus flight manual. It says it all. Good airmanship is more than just knowing emergency procedures. It's about developing a real feel for the airplane. It's about building that mental database of what pitch and thrust settings look and feel right for every phase of flight. That way, when the computers get confused, you don't.
So, let's go back to that interview question. What are your immediate memory items for an unreliable airspeed warning? The answer they are looking for is autopilot off, auto thrust off, flight directors off. Then you pitch and thrust for level flight according to the tables. Simple, direct, and it shows you know how to take command when the automation fails. The ultimate takeaway is that in a modern glass cockpit, the most important safety system is, and always will be, a well-trained, knowledgeable pilot. Study hard, fly safe, go get that job. And remember, this is for training purposes only. Always follow your company SOPs and manuals.